Here's just a quick overview of why, when the bearings are captured in the body of a rotary broach such as this, that the body of the tool has to rotate relative to the workpiece. So right now the bearings are on a 1 degree angle on the center line. However, when this is captured or held steady in a lathe tailstock, for instance, all will occur is the rotary broach is just going to spin on the center line of that bearing. Now granted, the bearing is off on an angle, but there is no oscillation that will cause the tool to wiggle into the workpiece. Now, very simple demonstration here. When you take and have this mounted, say oppositely, put the rotary broach in the chuck of the lathe, and then you have the workpiece stationary, you will then get an oscillation. You can see the body of the tool wobbling like this. So that is where you'll get the broaching action, is from this. This has to rotate relative to the workpiece. The workpiece in this case would be, in the case of a lathe, the workpiece would be stationary in either a tailstock or some fixture, and you chuck this end of the tool up in the chuck, and it will then work its way into the workpiece. This will also work, chuck this up into a mill, which then you have, a stationary workpiece, and then you have the broach do the action. Now here's a example of a broach I made for this. Now this broach cut aluminum, but you can see the tool tip, and this is just a high-speed steel hardened piece of dowel. You can see the tool tips are in good shape, not chipped or cracked. Each one of these broaches that I made, so this one's a hex, and that's a 7/16 diameter. The one on the actual tool, that's a 7/16 square. I forgot what that made that for. But the length, so the tip length from the actual cutting tip to the base here, I made the same. So that when the tool tip is oscillating, the total indicator runout ends up being a thou or less. So I just thought I'd put that together so you could visually see how that works.